teachers that we have with us tonight. Ms. Krakus, 8th grade. Ms. Orris, 8th grade. Round of applause. Ms. Johnson is our 7th grade teacher, and Ms. Golden is our 6th grade teacher. So we do appreciate you coming out tonight, and what we wanted to have you do is experience a math class similar to what your students are experiencing every day here at the middle school. And so I don't have I'm kind of staying in both places. So for the program that we're using, and it is new this year, is CMP3, Connected Mathematics Project. And each of the investigations in the Connected Mathematics Project has 3 components. And tonight we'll walk through each of the 3 components. We will have a launch, an explore, and a summarize. And so what you'll do tonight is kind of walk through those pieces and get to know what each one is about. I guess I should have had you a little closer. So the launch. In the launch, every investigation starts with a focus question that students are exploring. It might be related to mathematics, it might be related to something in the real world, but the whole point of the investigation is to answer a focus question. And so for our focus question tonight, that all of you will be thinking about and answering is this. What is happening in OLHMS Math? OLHMS Math, and how do I help my child? So by the end of the night, I'm hoping that you have a good amount of information of how you can answer this question. In addition to the focus question, the teacher during the launch is trying to find out what her students bring to the task. So what information do they already have, either about the mathematics or about the situation, and kind of through questioning might be one way to have students talk about some related question. Another thing that sometimes happens is if there's a video. And so the class watches a video, and then everyone has kind of a common experience that they can start to move into the explore with. And so I won't ask you any hard questions right now. We will put a video, I have a video that we will watch. And what the video kind of is going to start to give us some common experiences about the Common Core, so that we can kind of start to think about how what is happening in connected math may be different from what we did and why that might be. So I'll just ask you to watch this short video, and that we kind of talk about that.
So math in some ways is like baking. And math used to be taught as a recipe, as a series of steps you do, and then you get a result. And what you understand if you're a cook or a baker is that you add things in certain proportions for a reason. And that, your cake has to have this percentage of fats and this percentage of flour in order to work. And what Common Core tries to do is to do the same thing with math, sort of developing what they call number sense. And number sense is understanding more or less why we do the things we do. In a way that most people over 20 don't recognize.
We find ourselves tearing out our hair at the new math.
It's the same thing I do when I get a check at a restaurant. Draw a bunch of shapes and tell the waitress to find my error.
Parents taking to Twitter, posting unbelievably complicated homework assignments.
These math problems circulate. They just seem really nonsensical, which is really frustrating if you have a kid who has this simple problem that looks like it's being made way too complex for no reason. It's totally understandable why people would say, this recipe that I learned is the quick and easy way to do it. Why aren't they just teaching kids to do that? So for example, we all learned to borrow when we subtracted, but this doesn't really show you what you're doing. It doesn't really show you what borrowing is. And so one of the ways the Common Core tries to explain this is with a number line. Because subtraction is really about finding the distance between two numbers. You start with the number you're subtracting, and you take little hops up to a more round number. So you go 10 between 90 and 100. So you've sort of broken down this distance, and you add these numbers together. There's another method called the counting up method, and this is also for subtraction. Count up from 38 to 40. Then from 40, you want to go up to the next big round number, which is 100. Then you need to go from 100 to 300, and then from 300 to 325. So that's the distance between 38 and 325, are these numbers that I've circled. You get this idea in your head that numbers are flexible things made up of other numbers. 40 is a 38 and 2. The standard algorithm is the easy and quick way to do it. Students absolutely still have to learn to do it that way. But the idea is that this gives them a better understanding of what they're doing, and that there are a lot of ways to do this. There isn't just one right way to find the solution to a math problem.
So thinking about math as a recipe, does that sound familiar to anyone in their thinking about how you learned mathematics? Thinking about the steps that we had to do to solve a problem. And we're asking students to think about things very flexibly. Anyone have any ideas of how you think about things flexibly in math? Maybe some of our students do. That's okay if you don't now. I'm just trying to see if you have any information. Ryan, yes?
Like in something, like we use integer trips to show like why subtracting a negative would be the same as adding positive, because like at first it doesn't really make sense, but then you learn the rule and it shows why.
Okay, so we might have just learned the rules for doing that, but you're able to connect it to some kind of a model that makes sense of why. And so tonight, instead of doing things as a step-by-step process, we're going to do things where we're thinking flexibly about the task at hand. Just let me get back to my, hold on, that's all. That's okay. Let's see where we have. I've got a lot of parent universities also. All right. Okay, got that one. Let me just close up some of these things here. Sorry. So much for me being really helpful. Sorry. I don't know what happened to it. Sorry.
Yeah, I think it's just one of your tabs.
No, it's not. I don't see it up there. I put it in its own. So nobody had the video, but what it closed up on. Let me just go to my recent study. Okay. Anything else any of the teachers might want to say about the explore part of our lesson? I guess just the main focus is wanting the students to discover it. Less more of us telling this is how you do it, but it's more like oh, okay. Well, sorry. All right. After we do the launch, so the teacher has an idea of what her students understand. Everyone has this common experience, and now we're going in to let the students explore. And so you will participate and explore at your grade level, and the teachers have brought some of the activities that the students have participated in, or probably already did participate in, or will soon participate in, and give you an opportunity to use that flexible thinking and participate in the explore part of the lesson. And thinking about our focus question about what our students are doing here at OLHMS with the math. So is this all 8th grade? Yeah. Okay, all right. Go with the 8th grade. This is going to be good for sophomores as well. Do you have another child that's here, what grade, 8th grade, or are you in the right place? Okay. And then do the two of you want to try, well, we can try 7th grade. We have Brian here.
And then we'll do a little, he's seen the 6th grade.
Okay, we'll do a little bit of both. So we'll take about 15 minutes just to kind of explore what we've got going on.
And what's your name? Okay, so Ryan? Awesome. So you recognize these, correct? So it's really cool. We've got integer shifts. We've got our focus question everything else. Starts off with one of the days, the first thing. Okay. Cut your arguments. No, got it. Yeah. No, so these are really cool. That kind of visibly see the initiative. And our focus question is using this chip model to represent initiatives. With
all right, here we go. You guys are going to draw squares of various sizes by connecting the dots. Okay, that's all. So draw squares with as many different areas as possible. So if everybody looks here, I did one up here so you can see. This has an area of 1 unit square. Okay, so there are 7 more. Can you find?
Find as many as you can.
So 1 square per 5
Because these two together in a sense.
Yeah, 1 per. So I do 1. You're going to draw 7.
Okay, cool. So with the
On
first
each
one on everybody.
There's more spaces than you need, right? So you can have Sylvia and cross it out, that's fine. But there's 8 altogether. But just find as many as you can that have different areas.
And you can look down the area of the
Like 1 square on each one, right?
A different, but it'll be different size.
So, like you did, very good, 1, 2, 3. So she makes 4, 5 per square.
I hold up the generic.
If I couldn't do this, but I'm just explaining. He was getting confused. That's why we're all here and help. And this is how the classroom is. They help one another. You know, if someone's stuck, they say, "Oh, it's like this."
And these are all represented by
So they all just should have different sizes. Make sure that they're different size squares, and then make sure you're saying, well, what is the area? So you're
Yeah,
kind
see
of
how we
proving
put
that it's a
area
different
equals
size.
1. So tell us what, if you know, tell us what the area is, okay?
I didn't do this 8th grade.
Well, see, now you're making up time.
that'd be about in the real world.
But this is what they're all like talking in the group, and they're helping each other. And
Someone might get stuck, and they're like, well, I can't find the 7th one. Then maybe somebody else is like, oh, here it is. It's right here. I got it.
But we're not standing up and lecturing anymore. They are discovering it for themselves, okay?
That's not good.
That's not good.
Why are they paying the teachers then?
No, we summarize then, all their findings then. All right. Oh, so we should have, well, there's 1, so you guys should have 7 more then. Well, you guys put the 1, so 8 altogether.
So you're 5
dots.
5 dots, 4
units
What is
The
it?
length's 4
1,
units,
2,
but what's the
3,
area of that
4.
square?
Pairs, you're left with 4 blue chips.
4 units by 4 units.
Yeah, but the
But what's the
inside.
total area on the inside?
Plus
Goes on 4, right?
Yeah, you got it.
Four times
4 you can count.
See? And this is exactly how our classes go. And like my big thing in my class, I tell them every day 1,000,000 times is mistakes are proof that you're trying. Make mistakes.
How many are there?
Well, there's helping each other, right? You know.
You guys got the vertical, horizontal squares, correct?
All right, now get creative. Think a little outside the box.
Flexible thinking.
5 friendships.
Can you draw 1?
So I like being 8th grader. Huh? That's why I like being the only 8th grader. She's already done this.
I don't know this in geometry.
Look at Emily. Oh, see?
Let me see.
See?
Wouldn't this be 4 though?
A diamond, this is square. That's a
would
really
that
good question.
Would that area be 4, Emily?
Absolutely. I'll get you guys if you want.
2 by 2. Yeah.
Hang on, no. Is
No.
the diagonal just, yeah, is the same as going across?
In a square it is.
Oh.
No, she's doing too much homework.
No, now see, and I'm about to tell Miss Kirk because she's not doing enough homework. We want more homework. So I would ask my kids this. What's the length of that?
1.
1.
1. All right, cool. What's the length of that?
1.
1. What's the length of this?
1.
1.
Tricky. It's not 1. Imagine if I took this and I kind of
Yeah,
dropped it down, right?
Yeah.
It's going to end up like right here.
By
2, yeah.
So it's bigger than 1.
half.
It's not exactly half. We don't really. It's not half.
No.
Sexually seen and negative.
We don't really know the exact length yet.
It's half, isn't it? No. You cut it here.
Hold
it.
Versus like, how do you have negative?
A squared plus
B.
A squared plus B squared is C squared.
So this kind of.
He's going ahead. He's going to our next. He's going to our. You're right that cuts it in half.
She has an
It cuts the square in half, but the length
father.
isn't 1.5.
This kid has to be.
Yeah. It's longer than.
But it's longer than 1, right? You see that? But it's
Right,
longer
right.
than 1.
So, can you put area equals 8 in there? So,
It's really cool when we were talking about.
So Emily, she found that diagonal, and the area is 8. So Emily, what would the side length be if the area is length? Because that's what they're stuck on.
Right.
Well, she did this today.
Square root of 2.
What is it? Remember,
If the area of the square is 8,
8,
what's the side length?
side length?
But if you were looking at the different kind of real world scenarios.
She don't even know.
remember any of this in class,
2?
you see these positive, negative.
4?
Well, remember, we can test it, right? Because length, base times height is a square, right? So 2 times 2, does that give you 8?
2 times 2 equals 4.
So Emily is saying that's 8. The area is 8, and she's right.
So what number times itself will give us 8?
Still down at a negative 2.
4 times 2.
But it's a square root of 8.
I know.
The
square root of 8 times the square root of 8
No, it's
is 8.
square root of 4.
No,
Because
4 times 4 is 16.
No, right. The square root of 8 times the square root of 8
2.75 times
Yes.
2.75.
Yes.
So because with square root 8 times, like your mom said, the square root 8 times the square root of 8 is the square root of
16.
8. 8 times 8.
64.
64. And what is the square root of 64? 8. You're back to your area. Oh, see, you remember that from today.
I don't know what she just said.
Right?
So you're coming back to 8th grade, right?
I think so.
We're going to sign you up.
Well, see, I figured it out by taking 2 triangles.
And that's,
Beautiful.
Yeah. And so you'll see. Emily did it this way. So how did you? Can you show how you did it?
1, 2, 3, 4.
Okay.
It's base times height divided by 2. So it's 4 times 2 is 8 divided by 2 is 4. So it's 4 and 4 is 8.
So we took a whole day in class and we actually took shapes like this and we learned how we can find the areas. But it's not easy to just count like these.
No,
So
you can't. You can't
No, you
count
can't just
when
count.
you turn it on its side.
So that was one way, was, well, let's break it up into shapes we can find the area of. The other way is what Emily's doing, where you could also draw a box around it, find the area of that whole box, and then take out the pieces you don't need.
Yeah.
And that's exactly what we do. So we bring kids up on the board or the smart board and they show their strategies because it's all about, is one way the right way? No, there's lots of ways that you can get the answer, like you showed.
And that's what I showed her with the non-rectangular polyhedron.
Okay.
You break it up into little pieces and you find all those pieces.
Right. See? That's a good hand.
She kind of got
She's
that.
got problems because she's got an engineering and accountant. The girl is
You
dead.
don't help her. You just give her the answer.
Okay, so
Yeah,
This
there
is
you
what me
go.
and my boyfriend fight about too, because he gives his little sister, when she needs help, he just gives her the answer. I'm like, you can't just give her the answer.
Right.
You have to help her, you gotta lead her there.
Sure, how?
So this
But
is
the problem is when you're an engineer, it's faster for me to do it in my head.
Well,
to
he's
say,
got a
"Here,
math
this is
degree."
what it,
Yeah.
this is what it is, rather than, okay, well, now you got to
for you, but when it's somebody else, right? And I mean, as math teachers.
But this is why I'm not a teacher.
Yeah.
It's I didn't sign up for the teaching degree.
It's hard.
So let's try with everyone making another diagonal or
Make another
diagonal tilted square. We call it the tilted square, and see if you can find the area with a strategy that maybe how Emily did it or how Emily's dad. Emily's dad.
Melanie's wait,
Emily's dad.
You got a kid? I don't know.
So try and draw another tilted square. Try and draw a tilted square.
It was very competitive in class.
And the other thing that we went over is when they were drawing the squares, the tilted ones, is they had to have right angles. So they looked like they were squares, but they were a little bit off. They weren't a right angle.
1, 2, 3 times 1 is 3, divided by 2 is 1 1/2. 1 1/2, 1 1/2, 1 1/2. The total is 16.
So you're kind of doing the big box around it, take out the pieces you don't
That's
need.
exactly what the kids do. You just didn't do it. You did the box around, and you took it away.
Well, that's what I have it up here.
Right.
16.
So it's 16.
You can take them home if you want to play it.
16 minus 6 is 10.
So what I would
That's
say,
exactly what
if
we're
you were one
doing
of my
today.
students, because they work together, they're showing each other, I would say, can you draw that box
Good job.
in?
You got an A+.
Absolutely, but I would say, could you draw that box in though, so when you're explaining it, other people can kind of visualize what
Visualize the big-
you're saying, what you're talking about?
Well, you connect the
Can you draw the
second.
box?
No, she wants you to draw the outside.
Because you're finding those.
Yeah.
Because it's clear to you, because you did it, but other people are like, what are you talking
Well, I
about?
imagine the outside.
And you know
Yeah.
what, we use markers, we use, things that stand out, so we might draw the square and then
Yeah.
or color it in, anything to help them.
Trust me, in our 8 years,
exactly
so
what
far,
you
you're my
just
favorite
did.
math teacher.
Oh, thank you very much. This is the second one. She's on a roll. Thank you so much.
So do you see how how we kind of like drew it. You can draw the box around it, find the area of that big box, and then take out the pieces you don't need. Right? Or you could take this and split it up into like triangles and just find the area of those triangles.
You get to move one.
You sure we did this in 8th grade?
Or no, you probably didn't do this because we learned.
Not this way.
You guys probably learned differently. Or, right, we can split this inside up.
Emily?
Right, so here's 1, 2, 3, 4. These are both halves.
What is this?
So 5. These are both halves, so they make 1, 6, 7, 8. All right, that's another way you can do it.
Square root of 10?
Yes. Because, right, side times side equals area. So square root of 10 times square root of 10 is square root of 10 times square root of 10. Square root of 100. And what's the square root of 100? 10. We're back to the area. We go backwards. So that's where the square root comes in and the x squared. And we teach the kids that it is the opposite. You're squaring something and taking its square root. Is it time up?
My timer is not working. So do you have another thing you're going to do?
No, we're still having fun. Yeah, I just want to be able to show my little creation too. Have enough time for my little creation.
So what's nice is, I mean, what you guys are doing, right? This was one day of finding these squares, finding the area. That was one day. Then from there, we started talking about side lengths of the square. So now we start talking about a square root. Where does the square root come from? Oh, it's actually from a square because you know the area, so the side's the square root. So now they're starting to use this idea of square root. Then from there, today what they did was they just drew any line in a dot grid, and they can find the distance of that line because they can make a square off of it. So if you watch with this crack, they drew a line.
Today, they drew a line, and they took the marker and they highlighted, and we said, what's the length of that line?
Yeah, how big is that?
Well, again, everything builds on each day. So Emily, right? What did you do? Here's Emily.
She's on the spot. She didn't expect.
Poor Emily's like, why did I come here tonight?
I think she needs to go to the restroom.
So if we just draw a little one, okay, because that'll be.
So if we're like, okay, so actually, before you go, Kath.
Yeah.
So that's what we had here, right? And we were like, well, okay, it's not 1, it's bigger than 1,
Right.
it's not quite 2. So they estimated it's about 1.5. They got rulers. They were like, oh, it's about 1.4.
They did that, right?
All right. So now fast forward, we've now talked about square roots.
So then
now when we draw that,
so then, right, we're going to draw the square. So Emily was asked, and all the kids were asked, what is the side length? So now she's going to make a square because she knows if she makes a square, okay,
and she finds the area of that
Go
square.
ahead, and she's going to build that box around it because she finds that that's the way that she likes to, even though what you did is fine too. And she's going to find the area. So she knows the little triangles that are on the outside. Okay. Now a half, and then she's going to take the area of the whole square, which is 4, 2 by 2. Good job, Emily.
And then she's going to take out those corners she doesn't need.
Right. So now again, Emily, we know that the square inside here is 2, so the side S, that one that or any of these equals what?
If the area is 2, the side
is square
root of 2.
Which is 1.4 when they measured it with the ruler, so that was their estimate. And we tell them to be exact, we would leave it at square root of 2. And we talked about what is the square root of 2? What kind of number is the square root of 2, class? Irrational, very good.
But we haven't started that yet, right?
But kids know, right? And the kids know that.
This is double-sided. Okay.
It was the extra credit.
And this is my favorite part. My favorite thing we've done so far because I told them like I didn't know this when I was in 8th grade. Like I'm so
Learning
excited
too.
about
We learn
this.
with the
Yeah.
kids, yeah.
So like square root of 2. All right, cool. I don't know for me how big that is though. So then we taught them like, okay, how can we estimate what that means? So they came up with, well, it's between, the closest one this way would be like the square root of 1, which they know is 1. And if I go up this way, the next perfect square, we talked about perfect squares, is a square root of 4, which they know is 2. So then they're like, all right, so square root of 2 is somewhere between 1 and 2.
1.5.
And then we said, well, which one's it closer to?
1.
Closer to 1, why?
Yeah.
Because
You're missing a 3 in there.
no, because 2 is 2 away from 4. 1 is 1 away from 1, so it'd be closer to 1.
So it's closer to this one. So then they take that and they go, okay, so I know the square root of 2 is in between 1 and 2, and it's going to be closer to 1. So then we tell them, okay, just estimate. What's a number between these that's closer to 1? And then they'll just say, I don't know, 1.3. Maybe it's like 1.3. And we say, all right, let's test it out and square it. So what's 1.3 squared?
What do you guys find in the students?
2.6.
Do they grasp it easy?
1.3 times 2 is 2.6, right? So then that's when they start doing their math, right? 9, 3,
Some pull out the calculator.
Yeah, just for the sake of quickness.
Their motivation is, well, I want to learn.
3.69. 3.6.
Oh, did I do that wrong?
Yeah.
Thank you. 3.69. Okay, so 3.69. So then I would say, no, it's 1.69.
Yeah, because it's between.
I had it right.
It's between 1 and 2.
Yeah, I had it right.
1.7.
1.69. So then I would say, okay, was our guess a little too big or a little too small?
Oh, okay.
Too big.
Because we're trying to get 2.
Too small.
Too small.
So it's a little too small. So then we go, okay, well, let's go up 1. So then test that out. What's 1.4 times 1.4?
That's, yeah. Right.
And this is what we do. I just have one, like, all right, come on, guys, what is it?
And then sometimes they
1.86? Okay, so are we a little too big or a little too small?
Too small.
Still a little too small. All right, let's go up another 1.5 squared.
3.
Well, so you don't want to go that far because the difference here is
Right, it's going to be over.
0.2.
Yeah,
It's going to be
You don't wanna go
2.25, right?
So it should be 2.25,
Yeah.
right? So then we say, okay, are we a little too big or a little too small?
It's got to be like 1.42.
So now we're a little too big. So since this one was too small, this one was too big, it's got to be somewhere between these two, right? So then they're like, okay, so let's try a number between those, 1.45. And we kind of keep testing this out.
They can go without a calculator, because that's what it's all about. You know, don't just punch in, we can estimate and get. And so that's what we're saying, you know, take any square root, square root of 27, and what 2 square roots is it between that work out, and then try to estimate. So we try using, you know, the math without the calculator. There's times we use calculator, don't get me wrong, but we like to get through
You
it.
have to show them how to calculate it on a piece of paper.
I know, but yeah.
There's the way to do it.
Yeah, right.
Just like you do with long division, you can do it with a square root.
3 negative.
There's a method to doing it. I'll show you something. You go crazy.
So anyway, fast forwarding.
Yeah, so then
where we're going with this is now they know how to find a square root. Now they can find the length. They have an idea of what squaring something means. So this is all eventually going to lead to the Pythagorean theorem. So do you guys remember learning this?
Squared plus b squared equals c squared.
Which I know you already said. A squared plus b squared equals c squared. Did you learn this yet? Right? You remember this? When I was in school, I mean, they just told me this, I used it. I had no idea where it came from, right? I was like, all right, a squared plus b squared equals c squared. Sounds good.
So here we are. So here's your right triangle. Okay.
Right there.
And you remember, when you learn this, it only works for.
It only works for right triangles. So where it comes from is the A and the B, if you remember, A, B, and C, they're all sides of the triangle, right? So this would be like A, B, and C. So if I take A and I square it, what I'm doing is multiplying it by itself, and I'm making a square, right? Same thing for B, same thing for C. So according to this, the square that I make off of A and B, add them together, that should give me C squared. So this is just a cool little way to visualize it and see it, how it works.
My husband created this for me. That was my my little honey, can you do this for me? So I can show my students. Though Emily's the first one that's seen it. They won't see it till they prove it. Yeah, because the kids have not proven this yet. So until they prove it, I won't bring this out. Okay.
You are sworn to secrecy.
And then you can see.
You're sworn to secrecy.
So the square of A, square of B will always equal the square of C.
Not true.
No.
There's a little liquid there.
She's not
holding it right.
All right. It works. Trust me. Now, come on.
Your husband wasn't accurate.
No, he was. Actually,
we added a little bit more water.
Yeah, we added some of the water. Yeah. We're like, do it evaporate a little bit?
There we go.
But you can see visually that these two added together make the square, which I think is so cool. Because I remember seeing like this proof of this in college and being like, what? That's what that means? And so it's so, I think it's so great that like that's what they're learning now, is where this stuff comes from. And when you know that it's this, you don't forget it. When you understand where the formula comes from, you understand it. Like it's not something you're just going to forget. So you know when to use it. You know how you can use it.
And so then we would even show like how an acute triangle does not work with the diagram, and an obtuse triangle does not work. So there's so much that we could do. But we first had to have an understanding about squares and about square root and area. So like as
so it all
comes together and they can totally understand it. But the students will prove this. We will not tell them this. They will prove it themselves. Okay, through this new math curriculum. Then I will show this. But that's kind of just a little bit overview of our math
a little
program.
feel for kind of how it goes.
Emily, how do you like the new math program?
All right.
Can you elaborate a little bit more?
She better.
What do you like about it, Em? What do you like about it?
I like that we can like make new things and like prove things that we didn't get before.
And do you like working with partners and groups and helping each other? Because we do that a lot, don't we?
Yeah.
And Mrs. Kreck is always putting you with a different partner, right? To try to change it up and everything. It's good. Very good. Any questions? Questions for anybody else?
What questions do you have about what's happening?
You got the 8th one? It's a 5. You got it. You got it. So there he is.
What are the numbers?
So
it's
there should
one.
be. So in order. Go ahead. 1, then
4?
no 2.
There's a 2.
Oh, there's a 2?
And then 4. Yeah, there's a 2. It was a 2.
Okay.
Then a 4. Then a 5.
And
Then
a
it-
10.
The 8, 9, 10, and 16. Yay, class! Yay! Bravo!
They just kind of ended up.
You should have that pet.
So,
Yeah, it's pretty nice.
She sold the idea off a video online.
Yeah, I saw it.
She didn't invent it, but
It's a good.
But it's awesome, yeah.
Thank you. It's great. My husband took pride
maybe you
in
should just
putting
start
that
selling
together.
them, like just start mass producing them. Sorry.
So during our Explore, I'm just going to, if you can kind of explain for a short explanation of what happened in your Explore, and then this group can kind of share, and then we can kind of talk about what's the Explore part all about? What's the purpose of the Explore piece of the lesson? So who would like to start explaining to the other group what you did, we're talking about? Anyone at this table willing to do that?
No pressure.
Well, we saw that there are more than one way to do it.
And what
You
were
know,
you?
there's
what
the
were
way
you-
I learned when I was in school. She's learning a different way, but it still gets the same thing. But I think it means more to her than just saying, this is it, this is how you do it, with no explanation. You know, and it's good to have something that you can look at. You know, it makes it make more sense.
So that model.
Yeah, you carry it forward with you, you know, rather than just memorizing it.
And can you just explain like what, so the other group knows, what were we doing here?
We had dot paper, and you're supposed to draw different size squares inside with different areas. Okay, and then trying to figure out what the length of the side is. You know, and some of them are not, you know, they're not, you can't count to figure out what it is. So you have to use calculations with square roots and everything. You should be saying this now.
Okay, 6 and 7, yes.
Well, what we did for the 7th grade is we used the integer chips. So with those, what we did is, like blue is positive, red is negative, and like we used those to show like how the 0 pairs go together, and then it just makes it easier to visualize because like it gets weird with negatives because you can't really use objects to show negative, but this like shows a good way to do it.
And then the lone 6th grader.
Well, I guess, was this called the product game?
Mm-hmm.
Yeah. What I'm getting out of it is you really need to know your multiplication tables. Definitely. But it was really fun game, and I don't know if my student particularly knew it, you know, how to do it, or me to even try to explain it, even through the book. You know what I mean? How to do it. I kind of figured it out, like, with him, he helped me out to figure out how to do it and stuff like that. So I'm excited really to be able to go back and, you know, explain it. It's like, what did I learn today? What did I learn today? It was really kind of fun doing this, like, Connect Four type of thing and stuff. And, you know, being able, knowing that he needs to know, definitely know his multiplication tables to be able to accomplish what he needs to do.
Doing a lot of multiplying over there too. So this idea here of us maybe not knowing how to do everything, and I saw this happening at that table too, working together with a partner or with a group, and between the whole group being able to figure out, or between you and your partner, kind of this is what I understand about it, this is how I can kind of talk through it, and together have that combined understanding. Anything else you'd like to share about what happened in the Explore? Did anyone learn any new vocabulary in the Explore today? Integer, great. Hey, good job, Ms. Johnson. Any new vocabulary over here for anybody?
Well, now I know what when she was doing her homework yesterday, now I know what this UN squared is.
Yeah.
Couldn't explain to me what the UN squared was.
Oh.
So now I know what that is.
We were looking for
in the units, yeah, because we were on this kind of paper, unit squared.
Yeah.
Yeah, but we were looking for a unit of measure.
Got it. What is this?
What they come up with now.
So in the Explore, working in groups, learning about vocabulary, anything the teachers want to add about other things that are happening in the Explore?
I think what my favorite part is, and it goes back into working in groups, is on their own, they might not all be able to do it, and they would struggle. And they struggle even when they're working in groups, but because there's so many more brains there, and they bounce ideas off each other, they come up with it. And I feel like you learn more, you learn better when you struggle at first. And you have to try different things. And they're really becoming problem solvers, and not, you know, if something's hard right away, they don't just give up and say, well, I don't know how to do it. They're learning how to problem solve, and okay, let me just try this and see if it works. If it doesn't, do you have another idea that maybe we could try?
I mean, really, we don't get that. I don't understand it.
Yeah.
They talk amongst themselves to try to figure it out. We just facilitate. We just go around from group to group and how they're doing.
We guide them.
We ask them those questions. Yeah, but they help each other. That's what we're noticing, and it's really, and we're learning off of them. Like they're different strategies. We're like, wow, that's a great way, you know, to show it.
Like ways that we didn't even think about, they come up with, and it's like I just get really excited about the maths. but yeah, they'll tell me something, and I'm like, oh yeah, that's great, you know. So it's like, I don't know, I have fun with it. I just think it's fun.
And like you were saying, a struggle, but it's a good struggle.
Mm-hmm.
We find that it's really productive. Yeah. So we really like this program.
Question.
Yeah.
You say they work in groups.
Mm-hmm.
Now, do you see everyone participating, or is it just like half doing the work and the other half just copying what somebody else is doing?
No, you know what, because we're walking around, they're all involved, and it might be that they don't understand, but it's their job to say, hey, how did you get that? Did you first do that instead of just sitting back? But no, we don't really say them copying, because remember, they're going to be assessed, so they're going to have to know how to do it. So they really do want to learn how to do it.
And
so,
we check at the end of each class, we do these things called exit tickets, which you guys are actually going to do.
Yeah.
And that's an individual thing. So you've worked in a group, and you've all learned together, but then before they leave class, well, I'm going to ask you that question. I'm going to ask you this focus question again, and it's your job as a learner to be able to answer that. So then that gives us the chance to make sure that if they are just kind of like, oh, okay, yeah, all right.
And remember, we're going from group to group constantly. We, you know, it's 80 minutes. We are all over that room. And so we're saying, Johnny, how did you come up with that? So they are accountable. Yeah, so, but that's a good question. Great question.
You tell them to put their calculators away for a while first?
Yeah, there's.
Oh, the past couple days, yeah.
We're like, put it away, especially because we're estimating square root.
Yeah.
Any other questions?
Okay, we'll move out of our explorer.
I like it. You sold me.
You saw, thank you. You too, you were complimenting.
Okay.
I just vote for
so-
more homework.
We good? Last piece of the investigation is a summarize, and this is where we are now going to, as the teacher said, to talk about that focus question. We're going back to the focus question and seeing if we can now provide an answer for the focus question. So we talked about what we did during the Explore and some things we noticed about how we learn the math. And so, how are we feeling about this focus question that we started out with? Anything anyone wants to ask or say about that? We didn't get to the last part yet, but is this giving you a better picture of what's kind of happening throughout each of the lessons? Whose thing is up for the exit ticket?
Oh, I'll explain it. So
Okay.
if you click on exit ticket. So every day
Yeah,
at the end
right.
of class, we do an exit ticket. And this is different formats. We do different kinds of things each day, but this is one that we use a lot. It's called Poll Everywhere. And it's really cool. Can you make that?
And the kids can use their phone
Yeah.
or their Chromebook.
Or
okay?
their Chromebook. So you guys are going to do an exit ticket.
So if you have your phones.
So you can use a phone. All right. And how this works is we ask a question. So at the top it says, what is something new that you learned tonight? It doesn't have to be math specific. It can just be, about what's going on in class or how math learning is happening now. As opposed to how we learned it when we were in school. So if you want to text, what you do is you text to this number 37607. So that's a number.
That's
the phone number. And then you're going to text Kathleen.
The text box.
KARA 954 first, and that joins you into this. So you send that first, then you send in your response. So however you want to answer that.
Could that be caps?
It doesn't have to be.
No. Yeah, I know. I think it
doesn't
works.
have to be. So you text to that number, you text Kathleen.
And it's going to come up on the
Kara,
screen. So just put,
954.
something. Everybody try it and just say, do you have your phone number?
And then whatever your response is. And the kids get super excited when they get to use their phones.
I think so. Manny?
You gotta take journeys.
Huh?
I couldn't put two.
God.
Oh, there, it's here.
And if you need any help, just raise your hand, we'll come.
Kathleen, car 954.
So you send that first.
A.
Kara.
It says it could not be found, make sure you enter the keyword.
Check spelling.
K-A-R-A.
Yeah, K-A-R-A.
Yeah, see,
Oh,
it doesn't,
okay.
it's just the first four letters of my last name.
Yeah.
It's just when we register, that's how
All
it
right,
shows.
my bad.
Alright.
And once you send to Kathleen and Kara, you should get a text saying like you joined the group, and then you can send in your response. And so this is a way that we check and see that all the kids know, they can answer that focus question. I mean, we get an idea of how they're doing.
Service
Oh,
access
you're doing it?
denied.
Oh, I have to.
No, mine worked.
Okay.
Mine didn't.
Did you answer the question? Okay, yeah. So
Son
if you're in,
fixed
so
it,
now
it's
you have to
fine.
answer the question.
Mine was denied.
Oh,
Let's see.
yours was denied?
Yeah.
Kathleen.
Just type what we say.
Service
Yeah.
access denied.
Okay, Brian.
Is he sending it to 376?
07.
Oh, seven?
Yeah, try send it.
It should be, it's live, so it should be. Anybody getting it yet?
I don't think anyone's.
I'm in there.
Oh, they haven't sent it?
No, they haven't responded yet.
Oh, got it.
They're still
Okay.
using
Thinking
it.
about their answer.
Service access denied.
You should see though, once the kids do it once, they are really quick.
Yeah.
Like, this is done it's in minimal time,
There you go.
Oh, there it comes, all right.
Where's just them?
Can I move that over?
Oh,
No, just let it go. It'll
right.
readjust itself.
will it? How come it's like that, or should I?
It should. When somebody sends another one, it should read.
It should, oh, it really,
Because they'll look.
got it, got it.
Hopefully.
See, now mine readjusted, that's why. See how mine goes? That's good.
Should I refresh it?
You can.
No, it's not working.
There it goes, okay.
Oh, that's fast.
Oh, that's very nice, thank you. And the opposite pairs for the answer.
Oh, nice for that.
Yeah, the integers, yes, yes.
Opposite pairs for the answer. What's that?
I think that's what they did in the
That was-
7th
yeah,
grade
that was-
lesson.
yeah, grade activity was.
There's some. And so when we do this in class, sometimes it's just multiple choice, sometimes it's, you know, they explain something. The questions change every day. Sometimes it's like click on a picture.
Did everyone give a chance to?
I think some people might still.
We can switch back maybe.
Sure.
That's so that was our exit ticket. And then after the exit ticket comes homework.
Yay.
Every class has homework at the end of it. And so homework for us today, see what we have in here. A couple things. The family, well, let me show you, there's a website. CMP3 is a program out of Michigan State University. There's lots of support for parents. And so this link, it's just CMP3. Is this on your teacher pages?
I think so.
No, it
yeah.
says portal.
It
might
would
be on
bring you to
student
the
portal.
Michigan State
This is different than
website, and there's a lot of resources if you wanted to find some additional help for your student. That's one place that you can look for that. Another option is the family letter. I think 7th and 6th give out their family letter.
Did you write down?
Yes.
They got it? Oh,
Yeah, we
perfect.
have it, yeah.
Okay. And we email our, I think you guys do too, we email and give a hard copy. So
And I'll
every
take
unit,
one.
you
Just
should
look
get a
at it.
family letter.
Yeah, I got it.
Yeah, you got it.
Perfect.
Yeah, we got that one.
And there really is helpful hints on the back of how you can help
Yeah.
your child.
And then the last thing that
My
this
son
work
said,
that
"Oh, yeah,
made
we're
up
working on
is strategies to help myself. It's a little variety of tips of if you are stuck solving a problem, what can you do to help yourself? And this will come in handy in high school as well. So you're all set with it. You want one of your own there? So those are some things that you can do. Check your teacher's web pages. There's resources on there as well of places to get
Is
some.
this for the student?
Yeah.
This is, yes.
So we gave this, we went over this in class, in my class the other day, last week. And we went through every piece of, you know, what are some things you can do when you're stuck? There's a ton of different strategies. We talked about how, you know, they have the internet, like they can Google anything or find videos about anything. And then at the end, their homework was actually to find 3 other 8th graders that they can call if they need help. Or, hey, I forgot my book at school. Can you send me a picture of the page?
Okay.
So they all have that.
That concludes our math class for tonight. If you have other questions, we're happy to answer those. But I hope that you are now able to have a good idea of what your child is doing here at school each day.
Thank you.
Yeah, thank you.
Carmen.
Thank you.
Appreciate it. Appreciate it.